Let's move to the next problem. Question number 21 says a microscope is focused on a point mark on the piece of paper. Now the glass slab of thickness 6 cm and the refractive index 1.5 is placed over the paper. How should microscope be moved to get the mark in focus again? Dear student, the first case is this is some paper, and on this paper there was a mark, and from here we were looking through the microscope. The image was in focus. Now, what do you do in the next situation? There was a slab of thickness 6 cm kept on this on the paper, and mark is somewhere here. And again to refocus it. Now what happens when it is seen through the slab? There is shift in the image position. The object image becomes up, and what is the shift? That is equal to T 1 minus 1 by mu. Now what is mu? The mu is a refractive index of this one, so this will shift to certain distance up, and the shift T is equal to thickness of this glass, which is given 6, and 1 minus refractive index is 1.5 given, and this would be equal to 6, 1 minus 2 by 3, and that comes to be 2 cm. So due to this slab, the object image become at this point, and to refocus it, you have to move the microscope up by the same distance to refocus it. So this microscope should be moved by 2 cm in the upper direction. So the answer to this question is option number 2. So let's move to the next problem. Question number 22 says a converging lens is made up of material having the refractive index of 1.3. If it is dipped in a liquid having the refractive index of 1.4, then it will behave like. These are the 4 options. It is a converging lens, and what do you know? The power of the lens is equal to and 1 by R1 minus 1 by R2. And what was this? This was the refractive index of the glass with respect to the surrounding, 1 by R1 minus 1 by R2. And look at the question, it was a converging lens. For the converging lens, this comes positive as long as mu1 is less than mu2. But here, this mu1 is 1.4 more than 1.33. Therefore, this becomes negative. If it is negative, the nature changes. So a converging lens will behave like a diverging lens. Therefore, answer to this question is option number 4. The question number 23 says that a point source S is placed midway between two converging mirrors of focal length f as shown in the figure. The value of D for which only one image is formed. Now dear student, how this image can be formed? This is symmetrically in between place. One option is like that ray goes from here, strikes this one, and returns back to this point. Then this becomes C. If it is C, then this distance will be 2f. And likewise, the ray, as it goes from this point, from the C, returns back. Again, the image is at this point, and this distance also 2f. So one option is when the distance between the mirror is equal to 4f, then there will be one image. There can be one more option, and what is that option? It can happen that the ray goes from here, then it becomes parallel to this, and then returns to like this one. And from here also, it goes like this, and then return to this. Only one image will be formed. And this happens when this distance is equal to focus, because once the object is at the focus, then the ray after a reflection become parallel, and again from here will come back to the focus. So then this distance is f and this is f. Then the second, your distance is f plus f is 2f. So we have two options. So 2f is one option and 4f is second option. 3f is not possible. Therefore, the answer to this question is option number 4. Now dear student, question number 24 says a light ray is incident normally on the face AB of a right angle prism with ABC. Refractive index is given 2 by root 3 as shown in the figure. The largest value of theta for which the light ray is totally reflected at the face AC. Now if the light is to be reflected from this face, this is air and it has the refractive index of 2 by root 3. This angle is theta and this become your normal. So this angle of incidence at this face is equal to 90 minus theta. And you remember, if I is greater than the critical angle, then there won't be any emergence. And if I take sine on both sides, then sine of I is greater than sine of theta c. And what was I equal to? 90 minus theta is greater than sine of theta c. And you know that sine of theta c is equal to 1 by mu. So sine of theta c is 1 by mu and mu is given equal to 2 by root 3 and fill up. Therefore sine 90 minus theta is equal to cos is greater than the root of 3 by 2. Add root 3 by 2. So cos theta is greater than the value is equal to cos of 30 degree, or logically theta should be less than 30 degree. And the correct option to this would be answer number 1. If theta exceed greater than 30, the ray will emerge out. So let's move to the next problem. The question number 25 says, in the situation shown, the distance between the object and its MS is 30 centimeter. The object is 6 centimeter above the liquid level and the beaker containing liquid up to height of 12 centimeter is kept on a plane mirror. So this is a plane mirror. The refractive index of the liquid is, look at the diagram, what is given, this liquid is filled up to 12 centimeter and this is the mirror kept. Now the question asked is, a refractive index of the liquid is required. Now dear student, the distance between the object and MS is 30 centimeter. Now for this object, this mirror will form the image. But see, from here, the mirror position will shift due to the refraction. So mirror come to this point, and how much is this shift? That we can calculate. This is given that this distance is 30 centimeter. Therefore, the MS to this point, this distance would be exactly the middle, 15 centimeter. And this again will be equal to 15 centimeter. And this become the apparent depth. Then 6 plus h apparent is equal to 15 centimeter. And what is h apparent? 6 plus 12 by mu is equal to 15. So 12 by mu is equal to 9 and mu is equal to 12 by 9 and that is equal to 4 by 3. So refractive index of this liquid is 1.33 and the correct option is the second. To answer to this question is 2.